So I should draw 2 lines on this warm up. Draw the line y equals 2 and the line x equals -3. And like I said, I already gave you a hint here. Y equals -3 and x equals 5 are already drawn on here. So which one of these is y equals -3?
The bottom one. The one that's on the negative
One
3.
line left to right.
The vertical.
Okay.
Yeah, okay.
This one. I mean, it's kind of obvious. It's the one going through -3, right? This one's going through 5 over here. This one's going through -3. So y equals -3 is this horizontal line. X equals 5 is this vertical line. So the line y equals 2 is this line right here. And the line x equals -3 is this line right here. Okay, so what we're going to do today is we're going to talk about dilations a little bit. We've already talked about dilations this year. I can't remember. Oh, yeah, that was whenever we were talking about similarity. So that was a long time ago. But we've already talked about this. So we're going to talk about dilations first, and then we're going to go into compositions, which is everything basically that we've already been doing. Okay, so a dilation is a transformation that enlarges or reduces a figure. Okay, a dilation is a transformation that enlarges or reduces a figure. The scale factor is a number multiplied that scales a figure up or down in size. Okay, scale factor is a number multiplied that scales a figure up or down in size. All right, if the scale factor is greater than 1, it produces an enlargement. Gets bigger, it scales it up. If the scale factor is less than 1, it produces a reduction, gets smaller. And I'm not talking about any scale factors that are negative. This is just talking about positive scale factors. So on number 1, go ahead and plot those 3 points and make that triangle. All right, so it's going to look like that. Now, the transformation we are going to do on this is we're going to do a dilation using a scale factor of 3. So the way this works is very easy. When you do a dilation, you just multiply every coordinate by that scale factor, okay? I mean, again, that's what a scale factor is. It's a number multiplied that scales it up or down. So since this is a scale factor of 3, is this going to make it bigger or smaller? It's going to make it bigger, obviously. So all I'm going to do is I'm going to take the scale factor of 3. Everything gets multiplied by 3. All right? So what is -2 times 3? -6. What is -3 times 3? -9. Okay, let's go ahead and just do all the multiplying, then we'll plot the points. What's 3 times 3? 9. What is -3 times 3? -9. And then 4 times 3 is 12. And then 2 times 3 is 6. So let's plot those 3 new points. And one of those points is going to go off the grid. So just kind of estimate where that needs to be at. Yeah, never mind. It's going to take too long. Okay, so it's going to look like that. So that's all the scale factor does. It's going to either make it bigger or smaller. And of course, all these dilations we do are going to be centered from the origin. So it's going to dilate it out from there. Okay. All right. Number 2, go ahead and plot those 4 points. Couldn't let it go. All right. So on this one, we're going to dilate by a scale factor of 1/2. Okay? So scale factor of 1/2. Everything gets multiplied by 1/2. All right. Everybody in the pool here. So what is -8 times 1/2? -4. What's 6 times 1/2? 3. So this point dilated by a scale factor of 1/2 is going to be -4/3. What's -6? -6 going to turn into? -3, -3. 4, -2 is 2, -1. And then 8 times 1/2 is 4, 5. Okay, so it should look like that. So pretty easy. I mean, you just multiply everything by the scale factor and it gives you your dilation. Now, one thing I want to talk about real quick before we go on to the other side. So we've talked about this word a little bit through this unit. Okay, the word is isometry. Does anybody remember what the word isometry means? We just barely mentioned it a couple times. Okay, so isometry means a transformation that does not change the shape or size. So the first 3 transformations we talked about, translations, reflections, rotations, those like switch where it goes, but they're always identical after you do that. Is a dilation an isometry? No. Okay, a dilation is not an isometry because it definitely changes the size. It doesn't change the shape, but it changes the size. So a dilation is not an isometry. Really, of all the ones we're going to talk about, it's the only one that's not. Okay, so on this side, what we're going to be talking about here is a composition of all of these transformations. Okay, so we are talking about compositions. Compositions is just whenever you have more than one thing that's happening at the same, or bringing more than one thing together. Like, have you ever heard of shingles? A lot of times they'll refer to shingles as composition shingles or that type of shingle. Composition shingle is where you bring different materials together, okay? So when you're doing a composition of transformations, that just means you're doing more than one. You're doing several different types. Okay, so what we're going to do is, on this first one, let's go ahead and plot these 3 points A, B, and C first of all. Go ahead and connect them and make that triangle. All right, so that's the original triangle. Now, the first thing we're going to do is we're going to do a translation along the vector 4, -7. So what's that vector 4, -7 going to do? Okay, good. It's going to go right 4 down 7. Okay? So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay, right 4 down 7. Now, this is going to be B prime. 1, 2, 3, 1, 2, 3 is going to be A prime. And then 1, 2, 1, 2, 3, 1, 2, 1, 2, 3 is going to be C prime. And it's going to look like that. Now, you can see that it says then reflect across the y-axis. So this is where the composition comes in. We're doing more than one, and this composition is like a progression. It's not like we go back to the original one. It's we're reflecting the last one that we were on. So I'm not reflecting the original one across the y-axis. I'm reflecting the last one that we did across the y-axis. Okay? So I am going to be flipping the blue and black triangle there across. So how far is A prime away?
7. Oh, 8.
From the y-axis. It does say y, right? Yes. So how far is it away?
5.
It's 5. So I'm going to flip it 5 to the left along that same line. 1, 2, 3, 4, 5. Now watch this. This is what we call a double prime. Each new time you move it, you just add another line, another, one of those apostrophes or whatever. So this is A double prime. Okay, how far is B prime away?
8.
It's 8, so I'm going to flip it 8 to the other direction for B double prime. And then how far is C prime?
7.
It's 7, so I'm flipping it 7 this direction for C double prime. And it's going to look like that. Okay. So you can see nothing new. We're not doing anything new. It's just doing multiple of these within the same one. Okay, let's do one more. So go ahead and plot those 3 points, make that triangle here on the next one. Oops. Okay. All right, so there's the original one. Now the first transformation we're going to do is rotation of 180. We talked about this yesterday. So what's our rule on rotation of 180? Yep, you just switch the signs, okay? So I'm just going to write that up above here. What's 1, -1 going to turn into? -1, 1, just switching the signs. What's L going to turn into? -3, 1. And then 1, -4 is going to be -1, 4. All right, so let's plot those 3 new points. -1, 1 is going to be L prime. -3, 1 is, oh, whoops, sorry, no, it's K prime. And then -1, 2, 3, 4 is M prime. Okay. Then what's our next transformation? Reflect across the line x equals 1. So where's the line x equals 1? It is this line right here. So I'm reflecting this one, remember, not the original one, but the last one we did, reflecting this one across. So how far is M prime away from here? It's 2, so I'm going to flip it 2 to the other side for M double prime. K is 2 away, 2 that way for K double prime. And then L prime is 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4 for L double prime. All right. And then we have one more after this. What's our last one? Dilate by scale factor of 2. Now remember, it's the last one that we did. So I'm looking at that purple and blue one there. So what are the coordinates of this point right here? 3, 1. Let's just go ahead and write all the coordinates down. What's the coordinates of L prime here? It's 5, 1. And then what's the coordinates of M prime? 3, 4. So I'm dilating by a scale factor of 2. So all I'm going to do is everything here gets multiplied by the scale factor of 2. So what is 3, 1 going to turn into? 6, 2. What's 5, 1 going to turn into? 10, 2. And then 3, 4 is going to turn into 6, 8. All right, let's see. This is K, L, M. Okay, so 6, 2 is K, well, the triple prime. Okay, 10, 2 is L triple prime. And then 6, 8 is going to be M triple prime. And it's going to look like this.